What's up mga kachimik? No, and welcome sa panibagong episode with Sir Jello. Last time we've talked about ionic compounds. We have described what an ionic compound is, and we learned how to write their compound name, write their chemical formula with simple ionic compounds, with ionic compounds, with transition metals, and with ionic compounds involving polyatomic ions. So for this particular session, we are going to talk about describe covalent compounds. So we are going to describe what covalent compounds are and how they are being formed through covalent bonding. We are going to identify the rules in naming and writing the chemical formula of covalent compounds, and we're at the end of the session, at least be able to name or to write the chemical formula of some common compounds. Right, are you ready mga kachimek? Sige, without further ado, because it's 6 a.m. in the morning and I had trouble in Wi-Fi last night, that's why I'm recording it right now. So, let's go! Alright, now welcome back mga kachimek. So, as mentioned a while ago, we start by defining or describing a covalent compound. So, what is a covalent compound? What makes it different from an ionic compound? Now, first, let's decipher the two words. Compound, meaning it's not an element. No, it's not an ion. No, it's a compound, meaning a combination of two or more atoms that was once an ion, now electrically neutral. And then, it's a covalent. No? If ionic is a metal and a non-metal, covalent is a combination of two non-metals where they share their electrons. Now, from the word itself, covalent, meaning their valence electron are cooperating, collaborating, coordinating with each other. Valence electron are together. So that's your covalent compound. To formally define them, it's not the mighty band or instant glue, but rather, let me change the position of my camera. A covalent compound are molecules formed by covalent bonding. Meaning sharing of electrons. Atoms share one or more pair of valence electron to attain their octet rule. Or in a layman's term, we simply call them a combination of non-metal plus a non-metal or non-metals. Meaning, it can be two or more non-metals. Alright, let me return my face here so that I can talk to you directly by using the camera. So, which are the non-metals in our periodic table? So we have learned that these groups, particularly group 1, starting with lithium to francium, beryllium to Ra, and then boron, pababa, these are your metals. Even this point in the middle, so meaning ito, these are all metals. And if you notice, if you have your periodic table with you, you will notice that seemingly you have a ladder here. This lime, sorry for my hand. This one in particular, this is your semi-metal, These are your semiconductors. These are your semi-metals or your metalloids. Meaning, it creates a boundary between a metal and a non-metal. So, meaning, ang non-metals lang natin is this part. Very little, very small. And the next group is your noble gas. So, we will be dealing with this group when we talk about covalent compounds. Alright. Now that we identify what are the non-metals in our periodic table, let's have a glimpse in the difference between ionic and covalent compounds. So, again, common difference of the two is ionic compounds it's between metals and nonmetals, while covalent compounds are nonmetals. Or rather, ionic compounds is between metal and nonmetal. So this is how do we identify ionic compound. Once you've seen a metal in the compound, automatically ionic compound. It doesn't matter if it's a compound consisting 6 non-metals and 1 metal. Basta kapag may isang metal, automatic, that's ionic compound. No? That is formed by an ionic bond. When we talk about we take a look about their properties. Si ionic bonding, there's no definite shape, while covalent bonding has a definite one. Other properties, high melting point kay ionic, and high boiling point. On the other hand, low boiling and melting point kay covalent compound. Low polarity and more flammable si covalent compound. High polarity and less flammable si ionic bond. Now, this is the reason for the flammability is because covalent compound are mostly in gaseous state, while ionic bonds are in solid state. Some example are sodium chloride, sulfuric acid for ionic bond, and mostly nga, as I've mentioned before, these are mostly salts, while covalent bonds are our gases, the methane and the hydrochloric acid, liquid or gaseous state. Alright, now hopefully we've get a sense on how they differ, especially in physical properties. So what happens in a covalent bonding? Now, if you can still recall our ionic bonding, you will remember the important of the octet rule, where the metals would lose 1, 2, or 3 electrons to achieve 8 outer electrons or 8 valence electron to attain the configuration, the noble gas stability. And the nonmetals would accept electrons from these metals to gain the same stability. In covalent compound, that is their goal as well. If you can remember, every element would want to be in a stable state, just like the noble gases. So an example here is neon. If you have forgotten already, it should have 8 valence electrons. So I borrowed this from a Google slideshow, the images. So they want to attain the stability of these noble gases for visual purposes, because these noble gases have 8 valence electron. So let's count, mga chimek. Now we have 1, 2, 3, 4, 5, 6, 7, 8. Yay! Ang galing-galing ni baby. We have here 8 valence electron. Now, and again, noble gases have complete outer electron shells which make them stable. So, what happens when a non-metal, which is not a noble gas, is roaming around? He keeps on asking other elements to form a bond with him or with her. So, halimbawa, si Florine asking neon, "Pre, are you single? Let's form a bond." What do you think would be the response of my neon? No, I have complete outer electron shells, so I don't want to bond with you. Okay, easy go lucky si F, si F boy. So that sounds bad. Si F, so it will just look for another person to bond with, only to find out, ang makakapuno sa kanya is yung sarili niya lang din, diba? Hinahanap niya yung completeness sa iba, not realizing na siya pala yung bubuo sa kanya. Char. Si fluorine, nagkataon, another fluorine atom would want the same thing, to share either sana, if it's possible, kung meron sanang metal nearby, he just will accept an electron from a metal nearby, like our sodium fluoride, lithium fluoride. However, destiny does not permit. So to attain this stability, our F committed incest. Char lang. Incest ba yun pag sarili mo? Or kaparehas mo? Or kambal mo? Anyways, instead of giving one electron, kasi fluorine would not do that because he wants an electron, the same fluorine atom wants one electron, they decided to compromise. No? And by that, they share their electrons. So let me reiterate the definition. A covalent bond is a bond formed when two nonmetals, either two different nonmetals or two nonmetals just like fluorine, we have our diatomic atoms share their valence electron to attain the 8 electrons. Sige, let's try to count. We have 1, 2, 3, 4, 5, 6, 7, 8. On the other side, we have 1, 2, 3, 4, 5, 6, 7, 8. And as a result of sharing this one, they need to be together to attain the stability. So this is your F2. Alright, one of the diatomic elements. So you have no fear on ice-cold beer. So F for fluorine. Alright, hopefully it makes sense. So other elements would do the same. Say for instance this chlorine. It has 7 valence electron as well. So what it's going to do is to look for another pair. So chlorine atom would say I have 7 electrons in my outermost shell. I need one more electron to attain stability. Chlorine atom would be the same. But again, this is not true for all the elements. This is just true for our diatomic atoms, the non-metals. Ulitin natin, we have no fear on ice cold beer. See hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. These are your diatomic elements, meaning these are the only non-metals that can form a bond with themselves. Alright, hopefully that's clear. These are 7. Now, for the last objective, how do we name covalent compounds? And how do we write their chemical formula? So there are 4 simple steps in naming covalent compounds and writing their chemical formula. First step is this one. For binary compounds, meaning for compounds composed of 2 nonmetals, we simply state the name of the first element. And then, the name of the second element ends in IDE. So if you'll notice, we have H and F and H and I. So we need to identify these 2 elements, our H and F. So our H, and if you notice, by the way, during our discussion on ionic compounds, hydrogen is in group 1. But we've never ever used that to form an ionic compound. Why is that so? Aside from the fact that it's a non-metal na nakahalo lang sa group 1 because it has 1 valence electron. Imagine if a hydrogen would donate, would lose or would release its 1 electron. Diba? A hydrogen with 1 proton will only have 1 electron. And kung ibibigay niya yung kaisa-isang electron niya, anong matitira sa kanya, diba? That's genuine sacrifice. That's genuine martyrdom. But hydrogen would not do that. So, hindi niya kayang ibigay ang natitirang electron sa kanya kasi isa lang yon. So, either he will not give at all or he will compromise by sharing. That's why hydrogen has this color. Same with our non-metal. It's light green or lime or cyan. Anyways, that's the color. I don't want you to rely on colors because different periodic table have different sets of color. Just to separate them. Meron naman yung mga legend sa baba. Sana all legend. So, going back, again, similar siya sa ionic compound. We write the name of the first element and the second element ends in IDE. We change the suffix of the second element. So, this becomes hydrogen fluoride. The fluorine becomes fluoride. This one becomes hydrogen iodide. Excuse me. So this is the first step in naming covalent compounds. Easy, right? easy if there are no subscript. What if there's a subscript? Meaning an indicator that there are more than one atoms per element. So second step, for atoms with subscript or subscripts, we use prefixes to identify how many atoms of each type there are. So what are these prefixes? So here is our prefixes, at least the first 10 prefixes. If there's only one, we write mono, 2 di, 3 tri, 4 tetra. So I want to focus on some prefixes like tetra. Diba? In our polygon, we use quadri, or quadra, diba? Quadrilateral. For 4, we use tetra, like tetrahedron, tetrapack, meaning we have 4 sides. And then we have penta for 5, and the rest would be, I think, familiar because it's our elementary polygon prefixes. Confusing lang sometimes si 6 and 7. Oftentimes I see students being confused with hexa and hepta. If they don't have this table. Just remember, if you have 6, you have hex. Both have x. Sana all may x, diba? Char. And then 7 is hept. The opposite of hooray, hept, hooray, char. And then 8 octa, octopus, because octopus has 8 legs. And 9 is nona, nona. And then 10 deca, diba? Deca homes, pero there are more than 10 homes. Ba confusing? Char lang. What if, sir, there's 11 or there's 12? Can you still remember our prefix here? So we have 2, diba? Andeca and dodeca. Let me write here andeca, because there are cases we have 11, especially if it's a molecular formula, and then we have dodeca. Sige, again, I'll create a mnemonics for you, but for Bicolanos only. Now, if there's 11, we have 11, diba? That's 11. If we have 12, that's 12. The deca. Talino ni Sir Zello. Char lang, mga kalokohan. So, that's 11 and 12. So, paano pag 13? So, we go back to the prefix of 3. So, this becomes trideca. Kapag 14, tetradeca, pentadeca, hexadeca, and so on and so forth. So, easy to remember, right? And you have your internet at home. So, andali lang nito. So, let's name our 2 examples here. So, again, the first one without subscript is easy. And this one is a lot more easier. Redundant. A lot more easier. It is easier and more fun. At least for me. Why is that? Let's try this one. So, again, for atoms with subscript, we use prefixes to identify how many atoms of each type there are. So for S, we have only 1. We only have 1. However, there's an exception. If the first element has only 1 atom, we don't write the prefix mono. So we don't write monosulfur. We simply write sulfur here. Now we only use the prefix mono, at least the prefix mono on the second element. Sige. So this will just become sulfur, and then we have 6. So I look at 6. Pag 6 hex, so that would be hexa, and then my F, fluorine, but it should be in IDE. So fluoride. So this will become sulfur hexafluoride. Alright. The second one, I have my nitrogen, and I have 2. So 2 is di. So this becomes dinitrogen, and my oxygen is 3. So tri. So it becomes dinitrogen trioxide. Alright, dinitrogen trioxide. Hopefully it makes sense, no? So wala pala dun sagot. So let me write it here. So this becomes sulfur hexa fluoride. So we don't separate the prefix to the second element, but we don't combine the first element with the second one. So there's space na in between them. The second one is your dinitrogen. Yes, you have two. Dinitrogen trioxide. Alright. So that's the second step. That we use prefixes in naming compounds with subscripts. So again, as I said, there are 4 steps. What's the third one? This is a reiteration of the exemption that I said. Now, we use mono for the second element only, not to indicate that there's only one atom. However, we don't use it in the first element. Say for instance, this one, H2O, our water. It's funny if I can still remember the experiment we did with my senior high school students. We offered people in plaza a bottled liquid with a label dihydrogen monoxide, which is simply water, and they don't want to take it. We even offered them 20 pesos just to drink a cup, but they don't want it, because the moment they heard or the moment they hear terms like this one, chemical formula, chemical compound name, they panic, or they fear them. But not if you are a kachimec. So again, let's try this one. We have 2 and a hydrogen, so we use di. So this becomes dihydrogen. And I only have 1 oxygen, so this becomes mono. So again, I will only use the word mono for the second element. Nag-loading si sir. But there's an exemption again. That's the 4th step. Instead of saying monooxide, I will only write monoxide. Later on, I'll introduce the rule. And here, I have SF6. So, same with my example a while ago. This is just your sulfur with 6 hexafluoride. So, I don't use mono on my first element. So, that is my sulfur hexafluoride. Again, I would like to apologize for my penmanship in this digital era. And the last step, if you spelled out a name with AO or OO, what do you call this in Filipino? Diptongo. Hindi. Ang diptongo is yung parang may patinig at tunog patinig. Parang kalabaw. Tama ba? Cluster ba ang tawag? Parang hindi rin ang cluster kasi yung parang kambal patinig na ba ang tawag? Magkasunudan. I think there's no term for them. Magkasunudan na vowels, or patinig. Like AO and OO in particular. Like halimbawa, hexaoxide, monooxide. We drop the first letter, the A and the O, we change it to O only. Halimbawa, yung dihydrogen monoxide, our water, we don't say dihydrogen monooxide. We simply say dihydrogen monoxide. So, another example is this one. P4O6. So, 4, we have tetra. Our P is phosphorus. So, tetra phosphorus and then we have 6 again, hexaoxide. But since it's AO, hexaoxide, we simply drop the A and change it to O to become hexoxide para hindi siya awkward pakinggan. And another example now that gives us all the rules is our CO. I love this one because it summarizes all the rule. The first is just write the name of the two involved element. So we have carbon, and then we have oxygen, but the rule says change it in IDE. Second rule, if there's a prefix, we write the prefix. There's no subscript, so I assume there's one. Mono, I don't say mono in my first element, but I say mono on my second one. So carbon, monooxide. But the fourth rule says, if there's an AO or OO, I change it to O. So this only becomes monoxide. So there you have it, ladies and gentlemen. Carbon monoxide. What if there is 2? No, CO2. Familiar? Diba? That's the reason why we name them carbon dioxide. No? If the 2 consecutive vowels are IO or other than AO and OO, we simply copy them. No? Carbon dioxide. Alright? Now, hopefully that makes sense now. So how do we name covalent compounds? There are 4 steps. And first things first, before doing this, because oftentimes, the students would use the prefixes, identify first if it's an ionic or a covalent compound. If there's at least one metal, that's ionic, and you go back to our rule in naming them. But if it's a covalent compound, this is the easiest naming process for me. You use prefixes and you follow the 4 rules. There you have it, our naming of covalent compounds. So sample problem, we have CO2. Oh my god, I already answered that. NO2, N2O4. And then how about if we are to translate our chemical name or our compound name into chemical formula? Is it difficult or is it easy? So yeah, I'll give you time to answer this one. So just pause the video, because in a few seconds I'll be flashing the answer. Hopefully you pause the video. So ladies and gentlemen, mga kachimek, the answers. Hopefully you got it right. So should you have any question, you can comment down below. Clarification, comment down below. Please share this. Vlogger na si sir. Hit the like button. Click the notification bell. And if you haven't subscribed yet, please do subscribe. So that's it for today, mga chimek. Next episode, we're going to talk about naming acids. So there you have it. Thank you. Peace out. Char.